Okay, in this question here, we've been asked to state a safety precaution you take when using chlorine in a laboratory. So chlorine is a toxic gas. So what you would do is when using chlorine, you would use the fume cupboard to contain it. Then we're asked to write a word equation. So we're told here that chlorine reacts with hydrogen. So chlorine plus hydrogen, and it forms hydrogen chloride. So that's the product of the reaction. Hydrogen dissolves to form a acidic solution. State what we can see when blue litmus is placed in. So if you had blue litmus in there, it would actually turn red. And then chlorine has 17 electrons in its outer shell. Hydrogen has 1 in its outer shell. Complete the dot and cross diagrams. Okay, so chlorine's got 7, so I'm going to use the dots. 1, 2, 3, 4. Oh, missed the shell. 5, 6, and that would be 7 with the other dots. So that's how you would draw that. Just 1 mark. Name type of bonding shown. So here you've got 2 electrons being shared between the atoms. So when we have 2 electrons being shared, that is a covalent bond. Then we're told if solution of chlorine is added to sodium bromide, a reaction occurs. Give a reason why this reaction occurs. So what's happening here is the chlorine is more reactive than the bromine, and that's leading to displacement. Figure 8 shows some apparatus to see if a solution conducts electricity. Let's have a look. It says glucose solution and sodium chloride are tested. Glucose is a typical simple molecular covalent substance. Sodium, state what happens to that when glucose is in there. So if glucose is in there, because it's a simple molecular covalent substance, then what would happen is the lamp would not light up. State what happened to the lamp when the sodium chloride ion is tested. So then in that case, lamp would light up because that is an ionic compound and the ions are free to move. Okay, and the last question here, figure 9 shows the conductivity of a solution as the concentration changes. Describe how the conductive solution changes as it goes from 0 to 5. So what we need to do here is, in general, it increases and then decreases. So we can say that the conductivity increases initially before decreasing. And then we need to say, to get a second mark, it's always good to explain a number from the graphs. What I'm going to do here is I'm going to say, if you look at what's gone on, so when it's 150, that's when it's actually reached its maximum. So I'm going to say then that the conductivity increases from 0 to 150 grams to 150 grams per decimeter cubed, which is the highest conductivity. So you need to give a value using numbers from the graph to get the second mark in that answer.